Hello, everyone, and welcome to this BA Collab Hour Water Chemistry for Consistent Brewing. My name is Joe Damgard. I'm the Sales Activation Manager here at the Brewers Association. Before we get started today, I'd like to go over a few logistical things. First off, if you have any questions during today's webinar, be sure to use the Ask a Question feature at the bottom of the screen. I see that the chat is alive and well, but make sure if you do have a question, you put it over there so we don't miss anything that's in the chat. Other thing, if you have any connectivity issues during the webinar today, try refreshing your browser. If that doesn't work, put it in the chat and one of a BA staff member will help you troubleshoot that issue. Last but not least, we are recording the event today and it'll be available at this very same link after we wrap up. If you'd like to download the presentation slides, you can click that blue button at the bottom of your screen and download it from there. That's about it for me. I'm going to hand it off to our speakers for today. We have Mark Timmons and Ian Galloway of U.S. Water Systems. Why don't you go ahead and take it away, guys?
Okay, thank you very much. We're glad to be on here. Hopefully, we've got a few relevant things to say. The title of our conversation today is "If it's not broke, fix it." And what that kind of means is you don't have to sit around and wait for something to get out of control before you actually take control of it. In other words, we think that beer is mostly water. Last I heard it was anyway. And so if it's the number one ingredient in your brew, it sounds like that it needs to be treated that way. And I think more and more over the last 10 years, we've been involved with people that are very seriously treating their beer or their water for their beer. I'm Mark Timmons. I'm a master water specialist. I've been in the water industry over 45 years. All that simply means is that I've made a lot of mistakes over the years. I probably made more mistakes than anybody in the business because I'm always trying new and innovative things. And, a lot of times it's a mistake sometimes. Thomas Edison, they say, could tell you 10,000 ways not to make a light bulb. And, I probably could tell you 10,000 ways not to treat water too. Ian is a sales representative with us, but he's been in the craft beer industry for 10 or 12 years as a brewer, and he's worked for several breweries. And I'm actually going to let him talk a little bit before this is over. But Ian's got a lot of experience in brewing beer. He actually knows how to brew beer. I just know how to drink beer. He actually knows how to brew beer, but I know how to treat water. Important, though. Yeah, I think so. I mean, it works for me. Was going to change this and I didn't, but it's what's in a glass of beer. It could be a glass of tap water, but there's a lot of stuff in here that didn't used to be in here years ago. Now we're hearing about PFAS or PFOAs, which are, newly emerging compounds that are called forever chemicals. Then they've got things like Gen X and 1,4-dioxane and many others. And we've reached the point in our country that even the city water, we can't take the water for granted. Obviously, groundwater we can't take for granted, but the city's infrastructure is aging and it's very difficult to know what's in the water all the time. As your beer is being made, as it's condensed down a little bit, as maybe some of it evaporates or boils, you're taking a glass of water that may have 20 ounces and you're condensing it down to maybe 15 ounces, but it's got 20 ounces of contaminants in there. So we believe it's really important to treat the water properly so that you're going to give great tasting beer. That's a given, but also it's going to be safe and healthy for the people that drink the beer. I've been in the industry for a long time. I think I did my first craft brewery 20 some years ago before craft breweries were even a thing. But in the last 5 years, I think it's really changed. It used to be that when you were talking about treating water for craft beer brewing, you were maybe talking about a carbon filter, a vessel that has a couple, 3, 4, 5 cubic feet of carbon. Or maybe you were talking about a backwashing sediment filter, different tanks like this. And I would say 5 to 10 years ago, maybe 75% of the water treatment that we were doing was simply sediment and carbon filtration. Today, reverse osmosis has literally reversed the tables, and I'm not, no pun intended. But a reverse osmosis system is becoming more and more popular in craft breweries. And some people have different opinions about that. They think, well, is it good? Is it bad? Why would you want reverse osmosis? We're going to talk about those things today, but this just shows a typical, this is a 4,000 gallon per day. This system would make in a 24-hour period. It would make 4,000 gallons. Some brewers use their hot liquor tank for the water. Some people use an atmospheric tank like this. Ian can probably give you some ideas why you would want to do that. This is a backwashing carbon filter that takes out chlorine, chloramines, chemicals, and things like that because it extends the life of the membranes. And then this right here out front is an anti-scalant system. You can use a water softener, and if you do need a water softener in your building, some people use the water softener instead of the anti-scalant. But if you don't need to soften the water, the anti-scalant does a great job of preventing the membranes from scaling. The membrane then rejects the anti-scalant and takes it down the drain. So the anti-scalant comes in either 5-gallon buckets or 32-ounce quart containers. And, you know, they're, by my way of looking, it's better than carrying a 50-pound bag of salt. 32-ounce bottle of anti-scalant might last several months. So we've pretty well done away with water softeners, although you can still use a water softener if you like. We have skid mounted systems. Some brewers like to be able to move theirs around, and they can. Everything can be, it can be a turnkey plug and play system. It can be wall mounted. It can be floor mounted. We have all different types of reverse osmosis systems, you know, from anything to 200 gallons a day on up to 500,000 gallons a day. We did some very, very large breweries that are up to 500,000 gallons a day, and everything in between. So mostly on the low end, most craft brewers are, you know, are as far as whether they got a 30 or 60 barrel system or whatever. We're selling smaller RO systems, typically under 10,000 gallons a day. But if you have a large brewery, it's the same principle. It's just bigger. That's all. And that's our presentation, because we didn't want to bore you with a long-winded bunch of stuff. We wanted to listen to you, and we like to keep our finger on the pulse of the craft brew industry. We like to hear what you need, what questions you have. And so at this point, I'm going to, unless Ian wants to add some more, I'm going to turn it over to you to ask questions, or if Ian's got some things to add, he can do that as well.
I mean, I'd say you pretty well covered it. So.
Okay, we're done. See you later.
Looks like we do have one question so far, guys. I can jump right into that. We can see if others come in as we're working our way through.
Okay.
First one comes from Seymour. He asks, if you're a rural brewery on well water, how often should you be? Sorry about that. How often should you have your water tested? Where and how?
It's a good point. We have over the years, we've used a number of different labs, and over the last 2 months, we've evolved, and we're now with a company called Simple Lab out of Berkeley, California. And what they do is they don't really test water, but they've hooked up a consortium of over 100 labs across the country. And since we do thousands and thousands of water tests, we negotiated special pricing. For instance, they've got a water test that's $149, and we sell it for $99. You can buy it from us for $99, or you can go on their website and buy it for $149. Do the math. I think it's a little cheaper with us, but I would, a couple of times a year, I would do that $99 water test. We've got tests that go up to $2,000 if you want, but in most cases, it's not necessary. Usually the $99 or the $149 water tests are important, and I would do those once a year. If you wanted to do it every 6 months, you know, if I were a brewer, I would post the results. I would do the before and after and here's what you're brewing with. And I'd say we had it tested 6 months ago. I'd frame it and put it up so people can see it. Just my 2 cents. Do you have anything to add on that, Ian?
The biggest thing, especially when you're brewing with well water, like Mark just said, test it as frequently as you feel is necessary. But yeah, I would say every 6 months is a pretty good starting point. Just because that water can change over time. I mean, you may have bacteria one day and then you may not have bacteria the next day. That's just one example. But I'd actually just got done working with a brewery who needed to purchase something to treat the iron in their well. And they'd been brewing with their water for about 10 years and had no iron or anything present. And then all of a sudden, just out of the blue, they've got 3 parts of iron that they need to deal with. And we ended up going the hydrogen peroxide injection system for them. And I think it's working out pretty well. But I mean, that's just one example. That water can change like that. So it's always good to kind of be on top of that as much as you can. And, like Mark said, get it tested frequently.
We're big believers in hydrogen peroxide technology because you're not adding anything bad to the water. It's H2O2, it's hydrogen and oxygen,
yep,
which are the elements of water. And if you have iron, manganese, or sulfur, to properly remove those things, they usually need to be oxidized. And there's a number of ways to oxidize. Some people use chlorine, but chlorine is a great disinfectant. It's not a good oxidizer. Hydrogen peroxide is not a great disinfectant, but it's a great oxidizer. You can use ozone, you can use potassium permanganate, as I mentioned, chlorine. But for the most part, we have the best results, most predictable results, and consistent results with hydrogen peroxide. Does that answer your question?
All right, we've had a few more questions come in, so we'll just get right to those. Next one from Kent: how often should a carbon filter be back flushed, and what frequency to replace the carbon using a U.S. water system?
That's a good question. There's no pat answer, but depending on what's in the water, I mean, we even have carbon filters that don't backwash. They flow in the upflow fashion, and so they don't really need to backwash. But if you're going to use a non-backwashing carbon filter, you want to use proper sediment filtration ahead of it, probably down to 5 microns or so ahead of the carbon filter. But generally, I like to see it backwash maybe once a week, and it only has to go for 8 or 10 minutes. The latest thing that we're doing is all of our systems are operated with a smartphone. You just an Android or an iPhone, and you set the time, you set the regeneration frequency. You can individually set each cycle. You can look into your app and see how many gallons a minute you're using at peak, how many gallons you've used since the last backwash, how many historical gallons you've used. I mean, it really provides a lot of information. Last night I went home. I've got, we're cold. We're in Indianapolis, and we've been down there 0, and I've got 2 humidifiers in my house, and I've got 2 reverse osmosis systems feeding the humidifiers. And when it gets down to 0, those things pretty much run 24/7. And I looked, and there's 4 of us in the family, and I looked, and we've been using 700 to 800 gallons of water a day. I ran out of salt the other day with my water softener, and I looked in my app, and man, 700 or 800 gallons, but it goes really quick when you're using a lot of water for humidifier.
All right, next up from Brad: how much water waste is there in an RO system? Also, can you discuss options for reclaiming wastewater from RO system instead of dumping down the drain?
Mm-hmm. Good question. Our most of our systems are 80% efficient, which means they waste 1 gallon for every 4 to 5 gallons they make. Okay. Used to be just in reverse. I remember 10 years ago, an RO system might waste 6 gallons for every gallon that it made, and some of them still do. But with the technology, the way it's advanced, if you make 1,000 gallons, you might waste 200 gallons. And of course, if you want to reclaim that, you can reclaim it for cleaning, or some places just reclaim it into, maybe they have a couple of 500-gallon tanks, and they use it for their water, for flushing toilets, for sinks, whatever. I mean, if it's typical city water, it's not going to be that concentrated. It's not going to be hazardous to use, and you can certainly do that and reclaim it that way. You have anything to add on that?
I've had a few customers of mine, basically come up with systems where they're reclaiming their concentrate from the RO and dosing their chemicals in for their CIP and stuff. So that's another option. Historically, it depends on the quality of the water, like Mark said. I mean, if you're feeding with well water that's like 1,500 TDS or something, you may not want to reuse that water afterwards. But if it's like 200 parts per million city water or something, then, like he said, it really shouldn't be too big of a concern. Flushing toilets, CIP. Some people even throw it in a mop bucket and mop their floors with it after, and they can use it as wash down water when they're done. So I think it's situationally dependent on the quality of the water coming in, but yeah, you do have options.
Good point.
Thanks, guys. Aaron asks, what options are there for water sterilization before boiling?
In my experience, if you're talking about feeding out of a hot liquor tank, we would always just basically, just heat that tank up to 185 so you can make sure you're pasteurizing the lines. But as far as sterilization goes, if you're coming out of like a cold liquor tank, I don't know what kind of setup you've got, but in some instances, I would say the best option is going to be UV typically. At least in my experience, there was one time at a brewery I was working at where it was 30 barrel system. So, decent size, where I was getting ready to knock out, and we didn't realize that the gaskets on our heat exchanger were going bad. So basically we ended up knocking out with water from the cold liquor tank that had gone eutrophic. It had bacteria in it. That water had been sitting in there forever. And I ended up getting some of that eutrophic water into my wort, and I had to throw 60 barrels of beer away. It was not a good day. So I always, going forward, recommend that if you're going to, just as precaution, always put a UV on your cold liquor tank coming into your heat exchanger, just because, even if one of those gaskets, let's say you just change your gaskets, whatever, but as they start to wear out, it's one of those things where you want to avoid that happening. And I can tell you it sucks when that happens. So I'd say UV is the safe bet there.
Okay. Dana asks, are carbon filters effective in removing chloramine from tap water?
Catalytic, yes.
The key to taking out chloramine is, of course, chloramine is made by adding ammonia to chlorine, and that stabilizes it, and it keeps it from, you can't hardly boil it out, and it stays in the lines and it doesn't dissipate. And that's why cities do it, because it saves money, but it's harder to take out. If you really want to take out chloramine properly, you need to have two tanks. And the first tank needs to be GAC, granular activated carbon. The second tank needs to be catalytic carbon. It's made by a special process. Catalytic carbon takes out chloramine. But remember this, if you're using, let's say you're filling a tank at 10 gallons a minute, you don't want to get a 10 gallon a minute carbon filter. You want to get a carbon filter that's maybe 20 or 25 gallons a minute. Not because you need that flow rate, but what makes it 25 gallons a minute or 20 gallons a minute is its size, its diameter, and its contact time. The more contact time you have, the more you're going to remove it. So always, if you're trying to remove chlorine and chloramine, always make sure you have plenty of contact time, because the more contact time, the better you'll remove it. If the water tears through there very rapidly, you're not going to take it all out. And I think I missed part of the last question. How long does carbon last? It depends. I know breweries that change it out every 2 years. I know breweries that change it out every 5 years. Typically depends on the water supply, how well you're doing other pre-treatment, whether there's any sediment treatment ahead of it, and what their levels are of chlorine or chloramine. I mean, I've seen cities where they have 3 or 4 parts per million of chlorine. And if it was a swimming pool, the health department would shut it down if it had that much chlorine, but they're letting it in the city water. So most city water has maybe a half a part per million to maybe 1 part per million. And you might go 3, 4, 5 years. But it's not a bad idea to do it every 2 years. And you should also have a chlorine test kit. That's something that, really the test strips work great. And you don't send water out to have it tested for chlorine. It's very expensive to do it that way. Just test it right at the source.
Or if you're a dweeb like me, you'll just titrate it on the way to the filter.
There you go.
All right. Kevin asks the best filter type to maintain high flow rate greater than 50 gallons per minute. Looking for full brewery, all incoming water, sediment, active carbon, and iron manganese removal.
Well, it depends. 50 gallons a minute coming in, and it's going to depend upon the levels of iron, manganese, sulfur, and competing contaminants. Remember that term, competing contaminants, because if you're just dealing with iron, there can be other contaminants that are going to affect how you may need to remove that iron. So we always look at the totality of the circumstances when we're dealing with treating water. We want to know what the pH is. We want to know what the Langmuir saturation index is. We want to know the alkalinity. We want to know the hardness. We want to know chlorides, sulfates, carbonates, bicarbonates, all these things. These competing contaminants are going to affect how we're going to do that. I mean, we have backwashing filters that filter down to 5 microns that can go up to 50 gallons a minute, 500 gallons a minute, whatever you want. We have cartridge filters that have polyester cartridges that can flow up to 2,000 gallons a minute, 50 gallons a minute, whatever you need. So it's just not one size fits all. There's an old saying that an old carpenter told me once. He said, measure twice, cut once. And that's kind of how we do it. We like to really hone in on what's in that water, take that water profile, and then we can tell you exactly what you need to do to treat it and be effective and sustainable. Anything else?
Right.
Yeah. No, you covered it.
Okay, next in from Kurt. He says, RO is great, but for my brewery, it's out of our budget given the pandemic recovery. The city tests our water for us, and I use additions for brewing profiles, calcium sulfate, calcium chloride, baking soda, etc. Are there any other budget-friendly steps I can take until we can swing an RO system?
We offer financing. Joking aside, I mean, it's really just, I think starting with a carbon filter or something like that, as just a starting point is going to be better than nothing. And the nice thing too is that if in the future you do decide to move onto an RO system, you're going to need that carbon filter anyway as part of your pretreatment. So you've already got that step established. I mean, I would say that you really can't put a price on good water. I mean, the reality is that water is the majority of your beer. So, if you got bad water, I mean, I'm not going to say that you'll have bad beer, but it's certainly, you've got a lot more hurdles to jump over. And it's hard to hide. It's hard to hide bad water in beer. There was one brewery I worked at where our city water was so chlorophenolic that every single glass of Kolsch I poured after I got done brewing it smelled like a swimming pool. So, it was one of those things where, and the same brewery, just to stay on this topic, their method of filtration that they would budget for included 2.5 by 10 carbon filters, both of which I found out later didn't even have cartridges in them. They were just empty housings. So, it's one of those things where you get what you put into it, and the quality of the water that you're going to get is all dependent on, how much you're willing to put forward for that filtration. So like I said before, you can't put a price on good water.
Yeah, just to clarify that a little bit, if you put a sediment filter and a carbon filter, and that's all you can afford in the beginning, then great. You'll probably need that with an RO anyway, because people say, well, what's the best RO system? The best RO system is the one that has the best pretreatment. And so we consider sediment filtration and carbon filtration pretreatment. And you can never have too much pretreatment. In accordance with what Ian said several years ago, it's been maybe 12, 15 years ago, actually. One of the first craft beer breweries that I ran across was out in California, and went in there and had the beer, and man, that was just awesome. It was really great. And a few months later, I was in Texas and saw the same brewery, and went in there, and yeah, it wasn't as great, but it was okay. And then I went to one in Colorado a few months later, and it was pretty good, but it was different than the one in Texas and the one in California. And then they opened one up in Indianapolis, and I went there, and it wasn't good at all. Now, Indianapolis is a very hard water city, and we have a lot of chemicals, chlorine, chloramines, things like that. Long story short, that craft beer brewery is no longer here because people voted with their feet and didn't go there. So I can only tell you that you can control the quality of your brew from day to day with reverse osmosis. You strip everything out. You start with a profile of 0, and then you build that profile back up to whatever you want, and you can consistently produce the same beer day after day. And that's why we're big advocates of reverse osmosis. Yeah.
Awesome. Next in from George, how often should the biofilm be cleaned from the storage tanks?
I would say in my personal experience, because I've had RO both ways, where you're either filling a poly tank and using it as a ballast and filling your hot liquor tank or cold liquor tank from there, or you fill a hot liquor tank directly and you just have a pressure switch on your RO permeate line, so you don't get any backflow. But in my experience, I mean, we would turn that tank over every day. I know it sounds kind of wasteful, but even on days where we were doing 2 or 3 turns in a day, as that RO is pumping, that tank's going to refill, and we would honestly just dump that tank every day because we didn't want to chance it. I mean, as far as a poly tank goes, I mean, historically we would always just use a foam sprayer and spray out the inside and make sure to rinse it real well when we were done. But I don't know. I honestly, I don't think there's a good answer, but I think the safest bet would be to dump it and turn it over every day.
And we use a UV on just about everything, just precaution. I mean, some people say, well, I'm going to boil it, or I'm going to get it so hot there's no bacteria, and that's true, but it's just a safety precaution. If somebody ever complained that there was bacteria in your beer or whatever, then hey, we've got a UV. I mean, we tried to deal with that. So I mean, we do it just as a matter of liability.
Gotcha. Coming in from Chris, have you seen any brewers recovering and treating their wastewater to use in the brewing process, not just cleaning or pre-rinse?
The only one really that I know that's doing it especially well is Sierra Nevada. Well, and New Belgium does it too, but Sierra Nevada has it down pat. I mean, they have like an entire wastewater treatment facility on site out in Chico, which I think is pretty darn cool. On a smaller scale, if you're not producing millions of barrels a day, I would say that it's not exactly feasible. I mean, you could probably figure out a way to do it, but that's something that I personally would have no idea where to start.
In a typical brewery, maybe under 100 barrels, 120 barrels, I would say in most cases it's probably economically impracticable.
Yeah.
All right, coming in from Thomas, he says, I'm from Finland, where most brewers believe that municipal city water is perfect and it shouldn't be filtered, not even carbon filtration. Most people, including myself, wouldn't know about water compounds that are more expensive to test, such as THM, HA5, PFOAs. By experience, do you think that city water could ever be good and stable enough to not require filtration? Or do you think a sediment filter or carbon filtration should be a minimum equipment standard way to go?
I don't know if I've ever tested any water in Finland. I mean, theoretically, I mean, it could be. Aren't they sitting on the glaciers and all this stuff? And I mean, theoretically, but if you're chlorinating the water, you're making halocytic acids, which are trihalomethanes. They're carcinogenic disinfection byproducts. You're going to at least have that, and I would assume that they're probably chlorinating or doing something in their water. I'm not sure what they're doing, but I would think you would at least need sediment filtration and carbon filtration. That's just my opinion, based upon no knowledge of the water, though.
Okay, next in from Mike, how important is testing for bacteria present in if the water is being boiled for an hour?
Well, assuming you're sanitizing tanks and everything properly, and honestly, I mean, I would say that it's one of those things where it's good to know if you have it, but in a lot of cases, I mean, if you're just using this water, specifically for brewing, and you're going to boil it out every single time, probably not that important. I mean, but again, I personally would want to know exactly, everything that's going on with the water, so I would know how to address it beforehand. I also personally wouldn't want to chance it. I mean, if you have a completely, I don't know, if your boil is efficient every single time, and you're able to kill off all that bacteria, that's awesome. But not every system is going to be that way. So I would say, if it were me, I would want to treat it ahead of the brew. But again, that's also, I'm a little gun shy when it comes to bacteria based on my personal experience. So.
Most restaurants and craft beer breweries and things that are on well water where there could be bacteria, they're classified as public water supplies, transient water supplies, whatever it happens to be. And if your water is contaminated, it's going to appear in the public record. I know restaurants that have not dealt with that. And, when people were made aware that their water was contaminated, they didn't last. So it's one of those things that if you don't really want that mark on your public record if you can help it. But it may be okay for brewing and things, because if you're at 185 degrees, you're probably going to kill the bacteria.
I guess another point that I would make too is that if your water for your, assuming that the water that's coming into the brewery is feeding the entire building, you don't want bacteria-laden water in your tap room. I mean, that'd be a nightmare. So, I guess that's another big reason why treating it ahead of, it coming into the building or coming straight off the wellhead would be ideal.
Okay, question from Brad. Is RO water bad for stainless steel? Should RO water be treated prior to being stored for extended periods in stainless?
Not typically. I mean, if you leave anything at a lower pH than neutral in a stainless steel vessel, over time, of course, it'll pit it at least a little bit. But I would say, as a general rule, no. I mean, I had, there have been breweries where I worked at where we would, our entire brew house went down for periods of a week and a half, 2 weeks at a time. And we had a cold liquor tank completely full of our water, that I had the same fear that it was going to pit everything out. And after we dumped it and turned the tank over, I looked inside and it was fine. So I would say that, as a general rule, no, it's not too big of a concern.
Okay, we have David tagging on to an earlier question. Is there an economic size for an RO for daily brewing water use in the 500 to 1,000 gallon a day range? Well water also.
Yeah, sure. Again, it's going to depend on all the pre-treatment you're going to need ahead of it. So, of course, with the well, we'd want to see an analysis and get everything kind of ironed out as far as that goes. But yeah, we have a lot of economic options available for that size.
So typically, like a 30 barrel system is about less than 1,000 gallons, right? The math is.
Yeah.
So people think, okay, I need 1,000 gallon a day RO. What we need to realize is that it will make 1,000 gallons in 24 hours. If it runs 24/7, it will make 1,000 gallons. So if you're brewing every day, and most don't, but if you were brewing every day and it was making 1,000 gallons, it would never stop. It would just keep going and going. It's kind of like your car. If your car may go 150 mile an hour, but if you drive it 150 mile an hour, 24 hours a day, I guarantee it's not going to last very long. Same thing with RO systems. If you truly, if I needed 1,000 gallons a day, I would put a 4,000 gallon a day RO in, simply because it's only going to have to run 5 or 6 hours a day. It's going to use less energy. It's not going to have to work as hard. It's going to last longer. When we put systems in, we typically oversize them so that they don't have to work hard. We've got systems that have been in 20 years and are still working great because we didn't undersize them.
And just kind of to add to that, so like Mark was saying, it'll produce that amount over 24 hours, but that's also assuming you're feeding with water that's 77 degrees. So right. If you got cold water coming in from a well or from the city, here in Indianapolis, we got like 52, 53 degree water on average. If you buy an RO that's rated for 2,000 gallons a day and you're feeding with water that's that cold, for every degree below 77, the RO actually loses 2% of its production. So it quickly will have that production rate of that RO. And that's, you got to account for that too. The other thing is whenever I'm quoting ROs, I like to size based on what they think their expansion goals are going to be. So if they're planning on expanding or adding fermenters or anything in the next, year or two, we try to basically, for a couple of reasons, quote a system that you can grow into. The main advantage, like Mark just said, being that, By oversizing it a little bit, you're not going to be waiting on water. It's going to be a lot more efficient on the system. It's not going to be as taxing. But also, whenever you guys do expand, you'll be ready for the demand, the added demand of the water that you're going to need. So,
yeah, and the thing is, you really don't want to push it that hard. We run into, I can't tell you how often we run into this. We go out and we quote let's say a 4,000 gallon a day system, and the guy calls us back and said, all the competitors are quoting 1,000 or 1,500 gallon a day system.
Yep.
Why are you quoting a 4,000 gallon a day system?
Yep.
And we just say, it's because of our experience. I mean, I can't tell you how often, a lot of people are obviously driven by the cost because it's real money. It's, you have to spend the money. And if we give you a price of $8,000 for a 4,000 gallon a day system, and somebody sells you 1,000 gallon a day system for $6,000, that's $2,000. But I can't tell you how many times we get a call back 6 months later and say, I should have listened to you. I need to get another RO now.
Yep.
Because I mean, if you're going into business, you really want to make beer. And if you want to make beer, you're going to use more water, and the more water you make, the more beer you make, and the happier you're going to be, the money's going to be rolling in. So when you spend too little, you can risk losing everything. If you go too big, you're just going to save money on energy, and you're not going to hurt yourself. So we always advise going a little bit too big than a little bit too small.
Thanks, guys. We have another question here. How much importance does water hold in styles like spontaneous beer, like open fermentation batches?
That's for him.
I don't have a whole lot of experience with spontaneous fermentation. I can say that if you're using city water, obviously you want to take out any chloramine ahead of the wort, just because, obviously chlorine and chloramine can definitely have detrimental effects to yeast health and fermentation in general. You don't want any lag time or anything there. So as far as I know, I mean, RO is always going to be my answer. I mean, the cleaner slate you can get before you actually turn it into wort, the better it's going to be. Just because you have, like Mark was saying before, you have a lot more control. And I would imagine that, again, I'm not really the person to ask about spontaneous fermentation, but I can tell you that based on my experience, anything that you can do to make the yeast job easier, you should do it.
Thanks, Ian. Next in from Chris. With severe drought happening in the West, it's top of mind for us to think about ways to be more efficient with water. Can you guys talk about some ways you would recommend to conserve water in the brewing process?
We use an 80% efficient RO.
Yep, that's a big one.
Don't use a backwashing carbon filter. Use a upflow carbon filter, so you won't waste any water there. And use a cartridge filter for sediment filtration rather than a backwashing filter. Not using a water softener, using an anti-scalant is you're not going to have any wastewater there. So the only waste you're going to have with that kind of a system is going to be the 1 gallon for every 4 to 5 gallons that you make. And if you want to reclaim that, you can, and use it for flushing toilets. You could use it for watering plants, shrubbery. If you have any, you could use it for washing down areas that don't require ultra clean water. Those are just some of the ways. There's probably more.
All right. Next in, Tom asks, brew pubs often install water softeners. Can you speak to using softened water in the brewery?
You don't want to use it in your process, just because the added sodium and things can definitely mess with a couple things. Head retention for one, overall mouthfeel is another. It also depends on what styles you're brewing, but in my experience, you don't want to impart any sodium if you can avoid it. Now, granted, if you're brewing on a steam system and you want to put, you come to us and you want us to put together a package for you, so we typically, if it's a steam system and you got a boiler, we'll quote you a softener that can handle both the demand of the boiler and the pretreatment for the RO. But on something like direct fire, I mean, anti-scalant makes way more sense. But yeah, as a whole, don't use softened water when you brew. It's not worth it.
So a lot of breweries here in Indianapolis and in cities like Phoenix and parts of LA that do have water softeners, because if they have a food component, if they're doing any food service or washing any dishes or anything, they may definitely, and have boilers, they may definitely want soft water for that. And so, reverse osmosis was originally developed to desalinate seawater. So it's extremely effective at removing sodium. So
I guess I should clarify. You don't want to use. It's okay to use softened water, obviously, in the building. If you've got a kitchen and you've got appliances and things that you need to be feeding, just don't use it in the actual process water for your beer. Don't make your water with softened water if you can avoid it.
Just saw a follow up in the chat from Shane. He asked, "How does anti-scalant work versus water softener?"
Well, what makes water hard is calcium and magnesium. They're considered hard minerals because when heated, they form a scale. They stick to each other and they form a coating. And these hard minerals, calcium and magnesium, plug up reverse osmosis membranes rather readily because reverse osmosis removes the largest spectrum of contaminants of any water treatment process, and it removes calcium and magnesium real effectively too, but it plugs it up in the process. So what happens with a water softener is you're taking out the calcium and magnesium and replacing it with sodium or potassium. They're considered to be soft minerals. They don't stick. They won't form scale. And it's fine for membranes. I've been in this business a long time, and I was rather late to the dance. I always believed in water softeners. It was rather hard for me to accept that anti-scalant works, but now I almost always quote anti-scalant, except when somebody needs a water softener for other reasons. I was a diehard. I learned with copper plumbing, and I was late to the dance with the PVC and the PEX and all that. But now we've come to accept it. So I guess it's I'm old school. The anti-scalant, very simply, kind of works like a polyphosphate, if you want to know. Polyphosphate makes a one molecule thick coating on anything that it touches, but it won't attach to itself. It's not exactly a polyphosphate. The anti-scalant is. It's a proprietary. They consider this a trade secret. The people that make the anti-scalant, they don't divulge what's in it, but it's FDA and NSF certified. It's for human consumption. But the good thing is the membranes reject it. So we almost always will quote an anti-scalant rather than a softener. But if you want a softener, it works fine too. When I was younger, I didn't mind carrying those big bags. As I get older, it's a little tough.
All right, next in from John. Due to space constraints, I was looking into an on-demand filter, specifically a 3M Aqua Pure 904. What are your thoughts on this type of filter, and do you offer something similar?
What is it called again?
It was a 3M Aqua Pure 904.
Don't know what that is. Let me look it up. Why don't we go on to the next question, and I'll come back to it.
Sure, yeah. Do the reclaim injection pumps that pump back to the supply on house systems work?
On residential RO systems, is that what they're talking about?
Not exactly sure. That's all we have here. Reclaim.
There's no waste reverse osmosis systems, and what they do, they put the waste into the hot water side. Mm-hmm. We've sold those a little bit. We've had lots and lots of problems with them. It's not we sell all over the world, all over the country at least. And so it doesn't fit our business model. When we sell something, we have to make sure that it's going to work, and we're not confident in that technology. That's the long and the short answer. And I can go back to the AP 904. It's a carbon block filter. It's if it's from 3M, it's pretty pricey. The cartridge, we sell the same thing, but the cartridge is about a third the cost what we sell. So it's a good filter. There's nothing wrong with it. We just think the price is too high. By the way, we used to be a 3M dealer, and we felt like what we have done over the years, we have graduated from selling other people's products to having all our own products. All of our name's U.S. Water Systems, as you can see on this shirt. Most of our products are made in the USA. all of our filters are made in the USA. All of our housings are made in the USA. Our carbon blocks are made in the USA. Our pleated filters, everything that we sell is made in the USA.
We build our RO systems here in-house, softeners here in-house, carbon filters here in-house. They're all built by us.
Honestly, the only thing that's not made in the USA that we sell are the reverse osmosis membranes. I'm sad to say, because the American-made membranes don't work as well. We're trying some new brands right now. We would love to have it all American-made membrane, but the Chinese membranes work better than anybody's. And you know,
resin too, softener resin.
Yeah, the softener resin. There's no softener resin made in the USA. There's
no later this year though.
Maybe this year. Maybe they said last year, and they still haven't had it. The problem is the EPA regulations. When you're making resin, there's products involved, namely divinyl benzene, and there's regulations on dumping that back into the environment. Same thing with reverse osmosis membranes. There's a lot of regulations here. And, you know, we would love not to buy this stuff from overseas, but until such day as they make better membranes, which we're really hoping that it's going to happen later this year, they come from China, and I'm not happy about that.
All right, next up from Maya, what frequency would you guys recommend for physiochemical and microbiological tests?
I'm assuming you're talking about just your feed water. Honestly, I would say that there's not really a wrong answer. The more often, the better. I mean, you want to make sure that you're staying on top of it. You don't want any microbes or anything, you know, that might interfere with fermentation or anything that might interfere with your finished product. But as a general rule, yeah, the more often, the better. There's a big brewery here in Indy that does microbial testing every single day. And I think that it's expensive, but I think it's absolutely worth it.
Okay, Adam asks, we have cold tap water up in the mountains. How much efficiency do you typically lose as the water gets colder? Is it better to oversize the system or preheat the water going into the RO system?
You can do it either way. Typically, again, like I said before, you know, for every degree below 77 degrees, you're losing 2% of your output. So a lot of times what people will do is they'll basically have a tank that they're going to pull from that they feed through a tankless heater ahead of time and get that water up to ambient temperature. So anywhere between 72, 77 degrees. And, you know, we've had good results that way. Feeding through an on-demand heater is a little dicey, or it can be, just because there's no real way to guarantee how accurate it's going to be coming out. And depending on the flow rates and everything, I mean, if you're passing through a tankless heater at 25, 30 gallons a minute, you know, that water might be 80, 85 degrees when it's, you know, coming out versus what you may have it set at on the heater itself. You know, so honestly, I think the better answer is to just deal with the water temperature that you have and just size the system accordingly. And like Mark was saying before, you know, bigger system, more efficient, more energy efficient. You know, you don't have to run it nearly as long. Parts won't wear out as fast. You know, lots of benefits there.
If you have the room, you can just put a large storage tank in and let the water come up to ambient temperature. Yep. And that doesn't take any energy. It just takes space.
Right.
Of course, a lot of breweries don't have enough space. So it depends on the application. You know, you can put a hot water heater in and you can put a mixing valve and dial into temperature, but you know, that's expensive too. And you're using energy. So there's lots of ways to do it. Ultimately, you may just want to oversize the system and live with that, because for instance, if your water's 52 degrees versus 77, that's 50%. So if you bought a 4,000 gallon a day RO, it's going to be 2,000. You bought an 8,000, it's going to be 4,000. So, you know, you just, and there's not a great deal of difference between a 2,000 and a 8,000. I mean, the cost is a few $100s. It's not a great, I mean, maybe it's 1,000, but it's not a great difference.
No.
You know, you can justify that cost, and I would always go a little bit big. One other thing I'd like to add: when you're talking about a commercial RO system, you need to be thinking about a centrifugal multi-stage pump.
Yes.
There's a lot of people that are selling diaphragm pumps as a commercial RO system. They're also selling rotary vane pumps as a commercial RO system. And we call those very light commercial RO. We start at 2,000 gallons a day. All of our systems, 2,000 gallon a day above, use multi-stage centrifugal pumps that are stainless steel.
Yep.
We just use all stainless steel because what happens is if you're using a bronze pump, you can get a little corrosion. And by the time we test every one of them at our factory, we ship it out to you, and there's a little bit of water that's been in there. You can get a little bit of corrosion and things, and sometimes they'll, in 2-3 months that it sits, maybe you don't get it installed right away. Some of those will lock, the pumps will lock up. We don't have any problems with stainless steel pumps, so we just sell nothing but stainless steel because we don't get into problems. I mean, when we ship something to California or Florida or Guam or Hawaii, you know, it's hard to have to say, well, look, you got a bad pump, I need to send you a new pump. People just don't like that.
The other nice thing too is that with the bigger pumps, let's say you're going to expand your RO in the future, you know, you want to add more membranes, get more capacity. With a larger pump that's already rated for heavier duty flow anyway, already installed on the unit, all you got to do typically is just add more membranes and you're in good shape. So you can double, even triple your capacity if you want to do it that way.
I know we probably told you way too much, but
Thanks for that, guys. Jeff says that he lost a hot liquor tank to what he was told was chloride corrosion. Do you have any methods to reduce or remove this from happening again?
Reverse osmosis.
reverse osmosis. Reverse osmosis takes out the chloride. Yes, chloride will attack stainless steel in short order.
Yep. Think if you parked your car in the surf in the ocean.
Yep. Same deal.
Yep.
It's sodium chloride. In this case, it's chloride. It may be whatever, but it's the chloride is probably elevated. I'm guessing it's probably over 250 mgl or maybe 500. I don't know. It depends. But there's some areas that have really high chloride, and it'll really corrode things quickly.
All right. At what TDS threshold limit should the membrane be replaced?
Well, it's not so much the TDS, it's the percentage, it's the rejection. You know, when new, we're going to produce 98 to 99% rejection. I would say when you're getting, so if you're starting out with 500 TDS at 98%, you're going to have 10 TDS or less. I mean, it's not uncommon with 500 TDS, we put a new system in and we got 1 or 2 parts per million. But then as it starts diminishing, now, if you take precautions, the precautions are remove the chlorine and chloramine, proper pre-filtration, anti-scalant or softener. If you do that, it's not unusual to see membranes last 5 years. We have labs that use water 24 hours a day, but they have good soft water 24/7, 365. And I know of a lab that, you know, probably it's a 300,000 square foot lab that tests blood samples 24/7 around the clock. And their membranes, they just change them every 5 years, but they don't even diminish in quality because they've got great pre-treatment. So that's how you do it.
All right. Our last question as of right now. So if anyone has more questions, be sure to get them in here. But last question, what certain salts you guys find suitable for, whoop, my question just moved. Here we go. What certain salts do you guys find suitable for RO water whose TDS is between 30 and 70 and pH between 6.5 and 7.5, especially when you are brewing an IPA and lager, depending on types of malt and hops we are using?
Well, for everything that I've ever, learned when I was brewing was, if you're doing West Coast style IPAs, you obviously want to go heavier on calcium sulfate and calcium chloride, but the haze craze has kind of flipped that on its head. Now it's not uncommon to see, New England IPAs and things doing 3-to-1 chloride to sulfate. That's the nice thing about RO though, is that honestly, you really do just have a completely blank slate. So I guess the right answer would be, it all depends on what kind of water profile you're going for. Like, are you going for the right water profile for, like something you'd find in Pilsen in the Czech Republic? Are you looking for water that you'd find in, say, San Diego, California? Are you looking for water that's, in Wyoming? Really, I mean, the big ones are always going to be calcium chloride, calcium sulfate, in some cases magnesium sulfate, and things like that. But honestly, those are going to be the big ones.
Okay, Jim asks, what size water treatment system would you recommend for a 2-barrel brew house?
It's going to depend on how many times a week you're brewing, how many times a day you're brewing. If you have any plans to expand, like I was talking about before, but in a lot of cases, I mean, you could probably get away with, let's say, if you're brewing twice a week, 3 times a week, you could probably get away with something that's, 500, 750 gallons a day. Again, it also depends on your feed water quality coming in. It's hard to answer that question without more information, but I would say that's at least a roundabout guess.
So, I mean, just to put this in perspective, a true commercial RO, 2,000 gallons a day and above, are going to be in the $4,000 to $5,000 range. And that doesn't count pre-treatment or tanks or anything like that. Whereas a 750 gallon a day RO system that's not a true commercial one that uses a diaphragm or rotary vane pump might be $1,500. But the trade-off is those pumps don't last very long. So you might have to replace that pump every 6 months to a year sometimes. Depends on how much you're using. So it depends on what your budget is. I mean, if in a perfect world, if I were dealing with that, I would put a 2,000 gallon a day commercial system in, knowing I would never have a problem with it. But in the real world, where you have to write checks out of your own bank account, then I'd maybe go with the cheaper one and then try to get by for a while. So there's your answer.
Yep.
All right, we've had a couple more questions come in. This one from Thomas. For brewing strike water, do you think that one RO with non-RO water blend is more often better than 2 using just RO water treated with salts? Some say using only RO water, even if treated with salts, is not going to make good beer. Do you know anything about this?
In my experience, the beers that I've been happiest with, that I've brewed on a commercial scale, have been with a blend of RO to city water. Obviously, the ratio of the blend depends on what styles you're doing. So obviously, darker beers, you'd probably go heavier on city water than RO. But that's not to say that, you couldn't produce an amazing stout with 100% RO water. It's all about just getting the actual water dialed in regards to, so the big thing with RO is that when you're stripping all those ions away, you start throwing calcium chloride and calcium sulfate into the mix. You start acidifying your water, with lactic or phosphoric, whatever you guys are using. You're going to start to run into issues with buffering, where you may add a bunch of calcium chloride, and then you add your acid, and you check your strike pH, and you see that you're a little high, so you add more acid, hasn't budged, add more acid, hasn't budged, you're recirculating it, keep adding acid, and then eventually you go to check it, and the last time you checked it, it was like, I don't know, 5.4, and now it's at like 3, because you basically run into the issue with the buffers where you just couldn't find that ratio. So a lot of it is unfortunately just trial and error. But I would say that it's definitely possible to make good dark beer with 100% RO water once you get that dialed in. But for convenience's sake, and in my personal experience, I'd say RO and city water blend is just fine.
Now, when he says city water, typically what we do is we'll have a micron filter to take the sediment down to like 5 microns.
Yep.
Then have a carbon filter that feeds the RO, but we'll tee off of that and we'll tee off of that before it gets to the RO, and then we'll blend it with the RO water. So it's been filtered, had the chlorine and chemicals removed, and then it's blended back. We make a blending panel that has TDS. It has a TDS monitor that you can just dial in whatever you want and dial in I know some brewers that they keep tape over it because that's their stock and trade. They don't want you to know what the TDS is.
We also have one that can blend based on pH. So you can blend, let's say if you're recirculating your HLT and you're getting ready to mash in, and you're just adding RO water, city water periodically just to, sit there and adjust needle valves, until you get to the pH that you're looking for on the way into your mash tun. So that's definitely something that we offer as well.
All right. Brad asks if you've worked with distilleries for demineralizing water for proofing. What type of system do you recommend?
It's going to be RO for sure. Some distilleries are big into deionization after, just because they want that water as close to zero TDS as they can possibly get for proofing. But DI water is not palatable. The closest thing that I could relate it to would be is if you were to take if you're drinking actual deionized water, if you took a piece of gauze and wrapped it around your tongue, that's kind of the same feeling that you get from tasting DI water. So, yeah, I would say if it were me, I would just go RO. Some people swear by DI as well. So I think it just kind of depends on whatever your preference is.
Here's what you need to remember, though. And I have people say, no, I want DI water. Well, you should still use RO, and here's why. If, let's say you have 500 parts per million of total dissolved solid, just let's use it as a number. If you're using DI, and DI is resin that takes out the anions and the cations. The anions are chloride, carbonates, sulfates, chlorides, bicarbonates. The cations are sodium, potassium, calcium, and magnesium. The DI resin is going to take that out, but it gets exhausted in the process and either has to be replaced or regenerated. A lot of people bring in DI tanks, and they have a DI tank service that they take the tank back and they get regenerated. It's pretty expensive. Here's the bottom line. If you take city water and turn it into DI water using DI resin, it's going to cost you 45 to 50 cents a gallon to do that. However, if you use RO first, the cost will be 2 to 3 cents a gallon. Now, 5 out of 4 people struggle with math, but I think it's pretty easy to figure that one out. It's much cheaper if you use RO instead of ahead of DI if you need DI water. And we do lots and lots of DI systems where labs demand DI water. And if you want DI, we'll give it to you, but always use RO ahead because it's going to be a whole lot cheaper to make. I'll just give you a classic case. We had a glass company. When they're making glass, they require DI water. And when I went in and quoted this, they were spending $76,000 a year on deionization of their water. We sold them a reverse osmosis system and a DI system for $36,000, and they cut their annual DI use or cost down to $6,000. So they paid for the system inside of 6 months. Interestingly, after about another 6 months, they said the RO is fine. We don't need DI, and they cut out the RO and they eliminated the DI totally. So I'm not telling you how to do it. I'm just telling you the most economical way to do it.
All right. Kat asks, for a brewery and planning aside from the RO system, what are a couple other top items you would suggest to be considered?
Man, that is a very loaded question.
You invite us out to drink your beer, and we'll give you our opinion of it. Right. That's a good place to start.
I don't want to plug a side consulting business here, so I won't. But what I'll say is that honestly, power requirements are a big one. A lot of breweries that I've worked with that have been in planning, especially when they're getting ready to order their equipment, they don't exactly realize how much power they're going to need at any given time, how many GFCI outlets they're going to need, exactly how they want to run their lines, if they want to run transfer lines or just use hoses, how they want to set up their hot liquor tank so it's accessible for their CIP, things like that. I mean, it's just little details. I'm sure anybody here in this chat that's participated in building out a brewery realizes that if you're budgeting for a brewery that's supposed to cost $1 million, you better have about $5 million on hand ready to go, because anything that can go wrong will go wrong. So
a couple of years ago, my wife and I were talking about opening up a brewery because, what we were going to do I thought this was pretty cool. Here's what we were going to do. We were going to put our water treatment room right as you come in. So we're all have chrome and stainless steel and high-tech looking water equipment. And we're going to say it's all about water. Beer is 90% water. We do the best job. And Ian pretty well talked us out of it. We thought, okay, it might be $1 million. And he said, it might be $5 million. And I thought, okay, well, I'll stick to water treatment.
it's not.
All right, we have one more question here from Megan. For a tankless heater, is it best to let softened or filtered only sit in it overnight? We always rinse the RO out, but I've gotten conflicting answers on the options to use.
Well, in my experience, I mean, with a tankless heater, feeding with softened water is always going to be better because you don't want that heating element to, scale up or anything. Because like Mark was saying, when you heat that water, if it's not treated, it will calcify and scale. So as far as leaving it in the system overnight, I've never heard any negative effects of doing so. But again, I would say, better safe than sorry. Maybe just purge it every night. Just be careful.
All right, guys, that is the last question we have in the queue here. Before we wrap it up for today, I just want to thank U.S. Water Systems, thank Ian and Mark for all the great information today. Guys, do you have anything else to add before we wrap it up?
I was just going to add, if you, we've got some cool stuff. Like if you can read this, it says, "Water is life. Beer is 90% water. Therefore, beer is life." I've got these koozies and I've got these little coasters. If you send me an email, mark@uswatersystems.com, I'll send you some. So it's just mark@uswatersystems.com, and I'll send you some out.
Excellent. Thanks again, guys. Lots of great information today. Just want to remind everyone that this presentation will be available at this very same link shortly after we wrap up. You can also download the slides from the presentation today with that green button at the bottom of your screen. That's about all we have for you today. Thanks again to U.S. Water Systems. Everyone have a great day.
Thank you. Have a great day.